Okay, it says estimate the area under the graph by using the trapezoidal rule and then the midpoint rule with n equals 6. So we're going to make 6 subdivisions. We don't have a function to punch into our calculator to spit out the value for us, so we're going to have to do the actual approximation ourselves. So let's start with the trapezoidal rule. We have our trapezoidal rule formula written there, and we're going to go make 6 divisions, and we're going from 1 to 6, so that makes it easy. These will be my divisions, and I'm going to make trapezoids using the endpoints, something of that nature. So in each division, I use the 2 endpoints to connect them with a line, therefore making trapezoids in each of them. Notice also, just something to pay attention to, is that right here it looks like I'm missing a little bit of it, missing a little bit of it. Here I'm maybe going a little bit over, here I'm going a little bit under, and so forth. So let's label our x0, x1, x2, x3, all the way up to the. So we know we're going to use the very left one once, based on our formula, the very right one value, the y value only once, and then double all the ones in the middle. So let's go pull them out from the graph. We do know our change in x, or our width in this case, is just 1, because each division has a width of 1. So we got our delta x to be 1. Again, it goes up to 6, and there's 6 divisions, so it's 6 minus 6 over 6, or actually 6 minus 0. So if you're doing the b minus a business for reference, we have 6 at the end, 0 at the beginning, over n being 6. So of course that's going to be just delta x1, but you can already see that from the graph. So x0, f of x0 is the y value of 0. That's just 3, plus double the y value at the next guy, which looks like it's going to be a 5, plus double the y value at 2, which looks like it's going to be a 4, plus double the y value at 3, which it looks like it's going to be a 2, plus double the y value at 4, which looks like it's just under 3, so I'm going to just call it 3, and then plus double the y value at 5, which the y value looks like it is a 4, plus, not double, but just by itself, the y value at 6, which it looks like it's a 1 in this case. So add them all up, divided by 2, and it'll punch out what t sub 6 is in this case. So t sub 6 approximately for us is going to be half of, we get a 40 there, 20. So approximating the area using 6 divisions with the trapezoidal rule looks like it gives us approximately 20. Okay, next we're going to do the midpoint rule. So for the midpoint rule, I have to go make my 6 divisions again. So here are my 6 divisions, but this time I am using the middle of each interval, 1, 2, 3, 4, 5, 6, the midpoint of that interval, and I can visually pull that out. I don't have to worry about finding the average on the side or anything because I'm looking at the graph. I'm going to go to the middle between 0 and 1, and wherever that y value is, I'm going to make a rectangle out of it. So there's my first one. Between 1 and 2, I'm going to go right there, and I'm going to make my rectangle. There's my next one, and so forth. Okay, so I made my rectangles, 1, 2, 3, 4, 5, 6 of them, each one having a certain length based on what the y value is in the middle of that interval. So all I really have to do is add up a bunch of length times width, because I have rectangles and I have 6 of them. We do know again that delta x is the same. We can visually see that. We can also calculate it to be 1. We see all of them are exactly 1. So m sub 6 we'll say is delta x times all those other midpoint values that we find, and we take the y value. I guess 6 plus up to x of 6. In this case, we know our delta x is 1, and we're going to go find the values from here. So I go up to my graph, and it looks like that's a 5, that may be like 4.5 for my first one. The next one looks like a little higher, maybe like 4.7. The next one, how high does it go? Maybe like 2.8. Next one maybe goes like, I don't know, 2.2. Next one, it looks like it goes maybe like 3.5-ish. And then the last one goes up about maybe like 3.1-ish. We punch that in and we get approximately 20.8 using the midpoint rule approximation. Now, are we going over or under? We will have to do a little bit more analysis of how we go over and under. That'll be in the next video, but let's go get an idea. It looks like it's pretty clear what's happening with the trapezoidal rule. We get a feel like maybe we're going under because we're missing all this business, we're missing that. We're going a tiny bit over here, but not that much. This seems pretty right on, and here we're going under. So we're going under, 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 missing all those places. This is probably underestimate based on the way the graph looks. For midpoint, it's a little bit hard to tell the way it is because I am going under here, but I'm going over here. Again, in the next one, I'm going under, but then I'm going over. I'm going under by a lot, I'm going over by less. So under, over, under, over, under, over, it's a little bit hard to tell. Is this really an underestimate or an overestimate? Because I don't know the actual function, of course. And so we would need to do some analysis based on the shape of a curve, what might happen. And that's going to come up next.